Hi guys, and welcome to this my video on surface area, part of the General Maths Unit 1 and 2 course in Australia, but if you are watching this all over the world, it's still relevant. We don't write it different because it's in Australia. We might sound a bit different, although I have a British accent. Anyway, my name's Darren from Maths Guru. Thank you very much for watching. Hopefully this video is going to be useful. I'm going to work through a load of examples and, I'm going to give you the theory and all that type of exciting stuff. But, what am I going to go through? Well, if you want to know, pause the video, have a look behind me. Those are my learning objectives. And I'm pretty much continuing from the work we did before. And you're going to go, what work we did before? Well, I've already looked at rectangular prisms, square prisms, triangular prisms, cylinder spheres, and pyramids. And in the pyramids, we learned how many people were killed by camels a year. Oh my God, so many people. Now you're probably going to turn around and go, why on earth is there a picture of some random lady with muscles? Well, if you've watched Encanto, and my daughter is a massive Encanto fan at the moment, you know that's Louisa. And she is worried about surface pressure. So close as I could get to a pun in this joke. But basically, we are going to be looking at surface area. Now, before I go any further, if you want to head over to maffsguru.com, where basically you can sign up for free. Not a problem. Go in there, put in your email and your password and what have you. And then you're going to get access to the videos, the downloadable notes, the VCAR exam questions, and so much more. Now, obviously, yes, Louisa may have surface pressure, but I'm not worried about, under the surface. I'm worried about on the surface. Now, the hardest part of this whole topic, as I say here, is actually working out how many surfaces a shape has. And a surface is nothing more than a face. So in this situation, what I've just coloured in there would have been a face. How many faces does this pyramid have? Well, there's 1, 2, there's one at the back, 3, and there's another one there, 4. So in that situation, it's got 4 surfaces, yes? Well, probably not. Because what about the base? Because, as Megan Trainor says, it's all about the base, No. Anyway. So in this situation, you would be looking at trying to find out how many surfaces there were, and then working out the area of every single surface and adding them together. That's what surface area is. It's finding the area of every surface and adding them together. But, as I say here, there are some common tricks we use in mathematics. For example, they may tell you that a cylinder is open. Right? Now again, I know this is a pyramid, but what is a cylinder? Well, let's have a look at a cylinder. There is a very bad sketch of a cylinder. Yeah, now if it is open, all right, what it is going to try and tell you is that there is no top. So think of it like what can I think of that comes in a tube? I can't even think of anything other than jelly tots. So I'll go back to my jelly tots example. If I'd pop the top off, obviously I can pour stuff in it. Well, then it's not got a top, and so it doesn't have a surface, and in which case it has no area. It may tell you that a box is also open. That means, in fact, there are only 5 faces. Why is there only 5 faces? Because there's not one on the top. So we do this to try and trick you over and over and over and over and over and over again. All right, so that's a bit of a forewarning. Now, prisms and pyramids. Let's deal with a pyramid first. We're going to find the surface area of this square-based pyramid. Now again, if it's square-based, we know that all the sides have exactly the same length. And they've told me here that that length there is 8 centimeters. This double line here and double line there means they are exactly the same length, right? So this length here and that length there are the same, which would suggest they are always the same. Now, whenever I work out the surface area, I actually do things like SA with a little box. That just tells me that I'm working out the surface area of, in this situation, a base. So in that situation, the surface area is going to be 8 times 8. Hopefully we all know why it's 8 times 8. Because it's a square, and we do that times that. So that's going to give me 64, and in this situation, centimetres squared. Don't forget your units, guys. We've actually got here units of centimetres. Let's do our units. Right, what are we going to do now? Well, our pyramid has 4 triangles. It has 4 triangles there. It's got a triangle there, 1, 2, 1 on the side and 1 at the back. So I'm going to work out the surface area of just one of the triangles. And again, do you notice how these are basic shapes? We've got a square. We may have a rectangle. We may have a circle. We may have all sorts of different things, but these are all basic shapes that we know how to find the area of. What are we going to do now? Well, we know the area of a triangle is a half times base times height. All right, so let me see. Let's draw my triangle on properly. So there is my triangle. what is the base of that triangle? Well, we know the base of the triangle is this measurement here. So that is what, 8 centimeters? So this is going to be half times 8 times, and we want the height. Now, in this question, you're really lucky because they're not trying to trick you. The height of a triangle, particularly from a pyramid, is from the top all the way down the middle here. Now, that is the height we are going to look for. They will try and trick you in some questions by giving you the slant height, and that will be this height here. And obviously, if they do that, there are ways we can use it. But in this situation, we want our triangle, which is a half base. If I was to draw my triangle out so it was flat on, that's 8. And they're telling me with that line that that is 6, which meets at a right angle. And again, they very kindly put that right angle on there to tell me that that 6 centimeters is a height. So 8 times 6. Oh, no, come on. 8 times 6. Right, 8 times 6 is 48. Divided by 2 is 24 centimeters and squared. Now, obviously, I am just going to check that, guys, because I don't want to make silly mistakes. Now, I'm going to use the TI Inspire. ClassPad, guys, you know pretty much that your calculator has exactly the same functionality for the basics. So again, I'm going to do 8 times 6. I'm going to divide it by 2. Oh, no, I'm not, because I'm not hitting that. So I'm going to do 8 times 6 divided by 2 gives me yet 24. Now, obviously, a lot of people then say, well, I'm just going to add the 64 and 24 together, aren't I? And I go, no, because how many faces does our pyramid have, or how many triangles does it have? It has 4. So in which case, my total surface area is going to give me 64 plus 4 lots of 24. Again, we got 4 faces. I want to do 4 lots of this 24 here. So again, I could do that in my head. I'm not going to. 64 plus 4 times 24. Hit enter. Gives me 160 centimeters and squared. All right, happy with that? I should go. Right, so again, a nice example, looking at the area of all the faces, adding them all together. What about this? Find the surface area of that pyramid. I've just done it. Come on. Now, Cambridge, thank you very much for letting me use your examples and the stuff from your textbook. You guys literally rock. Thank you so very much. Now, we've obviously got here curved surface areas. These are taken directly from the book and really should go in your summary notes. Print off this PowerPoint, download it from mathsguru.com, print it off, job's done. It is in there. Now, surface area of a cylinder is given by this formula here. Now, I don't teach it that way, and if I've done this previously, then what you'll find out is I always talk about the surface area of a pyramid in the following way. I say the surface area is pi r squared plus pi r squared plus 2 pi r h. And you're trying to say, but hold on a moment. If I do a pi r squared plus a pi r squared, I'll get my 2 pi r squared, won't I? Well, yeah, of course you will. But that's not what I'm worried about, because I'm worried about the tricks. So what I do when I have my students is I actually write here, that's the area of the top, that's the area of the bottom, and that's the area of the curved side. Now, obviously, if they say that my cylinder is open, then I'm not going to need that one. And so in which case we just have pi r squared plus 2 pi r h. I think that makes life a little bit easier. What else we got here? We got a sphere, nice and easy with a sphere, right? It is 4 times pi times r squared. And what is r? Radius, yep. So when they've given you the radius of the sphere, all you need to do is square it, times it by 4 and pi. And again, that pi button is on your calculator. What about a cone? The surface area is given by pi r squared plus pi r s. What on earth is s? Well, again, that there is our slant length. How do you think they might try and trick you in an exam? They may give you the height and the radius and expect you to work out the slant length. And if you're looking at that now going, how would I do that? How would I do that? How would I do that? You'd have a right angle triangle. So that's where we mix some of the topics together. We can actually use a bit of Pythagoras theorem, all right, to try and trick you, or more importantly, to test your understanding. So let's find the surface area of this cylinder to 1 decimal place. And I've tried to give you here the formula. Again, I tend not to do that. I'm going to write it out my way to say that the surface area of a cylinder is given by pi r squared plus pi r squared plus 2 pi r h. All right, let's see. What does the r stand for? Radius. Have they given me the radius? I should Coco. They've given it here. Now, obviously, they've tried to trick you, haven't they? Notice that here the cylinder is actually standing up properly. This one, they've lied it down. Again, subtle tricks to try and mess with your head. What do you reckon H is? Well, H is basically the distance between the two circles. That's what I think of that one as. And so in that situation, it would be 15.7. Right, let's substitute it in. So we've got pi times radius squared, which is 8.5 squared, plus pi times 8.5 squared, plus 2 times pi times radius of 8.5 times the height of 15.7. Now, I know a lot of people turn and go, why do you do dots down the bottom there? Well, in the United Kingdom, we use that as a times, because otherwise, if you've got lots of these kisses all over the place, it gets like really long to try and write. And you'll notice there's a subtle difference between my times sign, which is on the line, and my decimal point, which I always put in the middle of the 2 points. Anyway, subtle thing I thought I would bring up. Right, what are we going to do now? Put in my calculator. It's the whole point of having a CAS, isn't it? Rightio, so here we go. It's going to do pi times 8.5. Hit my squared button. Oh, try that one again. Pi times 8.5 squared. Sorry, guys. I haven't recorded for a while, and so I'm a little bit all over the place with my calculator. Pi times 8.5 squared plus, what have I got? What about 2 times pi? The one thing I don't like about the TN Spy calculator is there's no separate pi button. We use it all the time. The fact I've got to do 2 clicks every time I want a pi gets me really annoyed. Times 8.5 times 15.7. Hit enter, and there we go. We get, ooh, that's not nice. All right, so does it actually give me a thing we want it to round it to? Yep, to 1 decimal place. And again, read the question, guys. You've got to make sure that we always round it to do 1 decimal place. So 1,292.5, and our units, centimeters and squared. Whew. There we go. Pi times 8.5 squared plus pi times 8.5 squared plus 2 times pi times 8.5 times 50.7. And there we go. What question we got next? Oh, sphere. Thank you very much. And again, thank you very much, Cambridge. We've got this nice graphic here to help us work it out. So I'm just going to write down there that my surface area is given by 4 times pi times radius squared. Let's write the times in long times now. So that's going to be 4 times pi times radius squared. Well, radius is 5 squared. Let's make sure here we notice that my millimeters. And again, fire up my calculator. What have I got here? So I've got 4 times pi times, well, 5 squared I know is 25. So there we go, 314 point. It wants it to 2 decimal places, 1 and 6 millimeters squared. Ka-ching. Thank you very much. So do you notice? Life here is really good. If you've got a nice shape and you've got the formulas in your summary book, you can just bang it in your calculator. Whoop. What do we got here? Find the surface area of the following shape, and it is a cone. Again, come on, we got the formula. So the first thing I'm going to do is write down the formula. Surface area is equal pi r squared plus pi rs. What does that stand for? Slot length. Yes. Right, so we've got pi times my radius squared of 0.95 squared plus pi times my radius of 0.95, and I'm putting them in brackets here just to make it look a little bit easier. So I know that that's 0.95, and what do I want? S is my slant length of 1.52. Fire up my calculator again, because I can't do that in my head. That was my very bad impersonation of a Scottish accent. My apologies to the whole of Scotland there, even though half my family are Scottish. That's a whole new discussion. 0.95 squared. What do we got to do now? We've got to add on pi. I'm going to times that 0.95, and I'm going to times that by 1.52. Hit enter, and there we go. Now, shucks. It hasn't actually given me what I've got to round it to. So I always say, if they don't do that, round it to 2 decimal places. That's, again, another British thing we were always told in the UK, to round to 2 decimal places. So I've got 7.37. What are my units? Meters and squared. Ka-ching. Right, ticks, trips, and tricks, and more tricks. All right, I think this is the last question I've got here, actually. They're not always going to give you the slant length of the cone. I told you that, yes, and that's where we have to use a bit of Pythag. They might give you the height and expect you to use Pythagoras theorem. There are types of questions you need to look out for in your exam, because we actually try and mix them all together. So here's an example. of a trick. A set of 10 conical paper hats are covered in material. Okay, so 10 conical paper. What on earth is a conical paper? It's a cone, all right? Again, bit of a picture, give you a hint. That covered with material. The height of the hat is 35 centimeters. So again, what I'm now doing here is they've given me, if I was to draw a cross-section of part of my hat, and I know it's going to be a right angle triangle, they're telling me the height is 35. It is telling me the diameter is 19, so they're giving me that whole thing there of 19. Notice how sometimes, or many times, we give you radius and boom, we throw in a curveball and give you the diameter. So what would we have to do? Well, we'd work out what 19 divided by 2 is. I'm doing that off screen to give me 9.5. So I now know my radius is 9.5. What is the amount in material in meters squared that will be needed? Whoa. So again, we've got lots of calculations happening here. So the first thing I'm going to do is find my surface area of my cone. Now my surface area of a cone is pi r squared plus pi rs. Let's just check. Not very good at remembering these things. So pi r squared plus pi rs. We're there. Pi r squared? Where's the pi r squared come from? Aha! That's the bottom. Because if you go back to my cone, the reason it's got pi r squared is we're adding the area of the bottom and this area of all this outside as well. Well, with a party hat, am I going to put material on the bottom? No, because then I'd never get the hat on my head. So again, I think I'm just looking for the section outside, which means we don't need the pi r squared. So there we go. So that was trick number 1. Right? What's trick number 2? So we know the area now is going to be pi times radius times slant length. We've got the radius. We've just worked the radius out as 9.5. But I don't know my slant length because the slant length has to be that length there, doesn't it? But I have a right angle triangle. So can I work out the length of that there? I should Coco, because again, what we would now say is call that x. We'd know that x squared would be equal to 35 squared plus 9.5 squared. We could work out my value of x, and I'm not going to do that for you at this moment in time. All right, I'm going to leave that to you because hopefully this has all worked, right? You can work out x as basically the square root of 35 squared plus 9.5 squared. And then that is going to be your value of s. So having done that, what am I going to do? I will do pi times my radius times my slant length. Okay, awesome. Is that my answer to part A? No. And again, notice how many tricks they've tried to put in this, because the question said it's got 10 conical paper hats. So having worked out the surface area for 1, you would then multiply that by 10. Whew. So that was part 1 of the question. What on earth could they go on to for part 2 or part B? Tinsel is placed around the base of the hat. How much tinsel is needed? Well, if you think about the base of a hat, if I took that hat and turned it around, we'd have a circle. There you go. So in that situation, it had very little to do with the work from this chapter. We would have needed to have known that circumference is, what is it, pi times diameter. Did they give me the diameter? They did. It was 19. So there we go. So in that situation, pi times 19 will give me how much tinsel would require for 1 hat. And then I would need to multiply that by 10 to give me the 10 hats. Now again, hopefully that wasn't too fast for you. The great thing about video is you can go backwards. You can sort of go, nah, didn't get that. Go back. You can go, oh, I hate his accent. That's okay. Go back. I can't change my accent. It's the way it is. Yeah? But the point of the video is you can go back, slow it down, look, go think. All right? But actually, believe it or not, that there is the end of this video. Thank you very much for watching. Hopefully it has been useful. If it has, leave some comments below on YouTube. Let your mates know, your teachers. But most of all, if you can do me the honor of subscribing, it just lets me know that people are watching. If you can subscribe to my YouTube channel, I would be stoked. It's the smallest thing you could possibly do, and it means the world to me. All right, I'm going to go off and record another video. Hopefully I'll see you in that one as well. If not, you take care, guys, and stay safe. Bye-bye.